Hello, everyone. My name is Patrick Ronan. I am the Life Safety National Account Manager for Current Lighting, and I appreciate Lighting Systems giving us this opportunity to talk a little bit about our central lighting inverter, specifically our single-phase unit, and when would we use a single-phase lighting inverter versus some of the other UL 924 product systems, such as a luminaire with battery packs or an emergency lighting fixture. As you can see with our single phase inverters, we actually have a wide range of sizes. So we go from our light power, which is considered a mini, which is 20 to 55 VA. Then we go into our light gear. And you'll notice on this slide that between the light gear and the Synchron, we do have some overlap. The biggest difference between these two machines, just so you know, with the Synchron unit, we have more options for you, more breaker slots, which is often important depending on what you want to do with the inverter, maybe outside of lighting itself. With light gear, it's pretty down and dirty. With this unit, we typically will see it in multifamily, where the main priority is to just make sure we light our path of egress. There's not a lot of other things that we need to have on here. There's only 4 breakers available on that unit. So again, please keep that in mind. If you want more options, then I would suggest going to the Synchron. The unit that we're going to talk mostly about today is our LSN, which is goes from 1 kVA up to 17.5 kVAs. This unit has many options to it. You'll also compete against other manufacturers with this unit in most cases. One of the things that we have to take into consideration when we talk about our central lighting inverter is code. As you can see, there's several codes here that are related to UL 924 product. The one that we're going to focus mostly on today is the NFPA 101. Now, this particular code really goes around lighting our path of egress, as well as the testing requirements, both monthly and annually. Testing compliance. So under NFPA 101 life safety, there has to be monthly testing. A functional test must be conducted every 30 days for at least 30 seconds. Why is this important? Obviously, we have to make sure the product is in working order. But more importantly, as we go through this presentation, you'll notice that these are more decentralized systems versus the inverter, which is a centralized system. We also have to have annual testing, full duration test, which is 90 minutes. It must be conducted annually, and equipment shall be fully operational for the duration of the test. And then finally, record keeping. Written records of visual inspections and tests shall be kept by the owner for inspection by the authority having jurisdiction, which we also refer to as AHJ. The other thing that you'll find with a lighting inverter versus the other types of product is a lighting inverter will also maintain testing records. I believe our units maintain up to 30 records. So if you did have an inspector come in and they wanted to know when the life safety products were last tested, you can actually pull this directly from the unit itself if you can't find the log that you're supposed to maintain. When to consider a central inverter? When generators are near or at full capacity or where restrictive to install. You'll see this oftentimes in data centers, for example, or healthcare environments, hospitals specifically. When using only specialty or decorative lighting in an architectural space, not available with onboard backup. So this is pretty obvious. These are smaller fixtures. They don't have the room for a battery backup, but they have to be used to make sure we maintain the proper path of egress. So this would be a good example, again, to use an inverter. Spaces with high ceilings or wide open areas. Warehouses are a good example of this. We're starting to see more warehouse business and opportunity out there. So a lighting inverter really helps the customer out because they don't have to worry about going out and buying a lift or a cherry picker. They can actually do all the testing from the floor, and they don't have to worry about getting that equipment or somebody possibly falling or getting hurt. when the space or building requires many lighting units to illuminate the path of egress. A good example of this would be a large commercial building. Emergency lighting backup solutions. So basically there's 4 types of UL 924 emergency lighting products. We have our central inverter, which we've talked a little bit about. We have our generator as well, our EM battery unit, and our onboard battery packs. I would like to add to the onboard battery packs is you also obviously can purchase separate batteries that can be installed above the fixture itself to help with the path of egress. What I would like to say here is you can see the system installed cost for an inverter is between that of a generator and an EM battery unit. Versus a generator, you don't have to worry about maintaining it like you do with a generator. Make sure it has the right oil levels, fuel levels, and so forth. An inverter is a lot cleaner. It doesn't have that exhaust. If your customers have an issue or a challenge, possibly with meeting certain environmental requirements. You can see on the far right with the wiring installation, an inverter is right in the middle of the road. It's not too difficult, not too hard. Whereas you look at a generator, it's much more difficult. The least expensive is your EM battery unit, which is an all-in-one system. We've done a little bit of a cost analysis here. This data is based on RS means. This data is from 2008. Again, when we look at this, oftentimes people may not think about this because they're more focused on cost. But I will tell you, if you're an end user or the customer, going with an inverter, a centralized inverter lighting system on your job is probably over time going to be a lot less inexpensive for them. Even though the upfront cost might be a little bit more, it's long term, it's going to be less expensive to maintain. And again, these numbers that you see on my slide are based on 10-year, and we use the 10-year requirement because the batteries for a lighting inverter minimum or 10 years, which most of you may already know, which is a 1-year prorated 9-year. So over that 10-year period, when you're looking at either, in this case, the emergency lighting fixture or the luminaire with onboard battery, you are looking at a much higher cost compared to the inverter, anywhere between $4,000 and $8,000. So long term, I know this is a difficult conversation to have sometimes, but long term, the inverter is a much better and more reliable system than the other 2 options that you have here. This is just another example. If you use a battery unit luminaire, you do your monthly tests. In this particular case, we're talking about 1,000 units versus 1 inverter. So over that, having to test every month, 1,000 units based on the hourly wage, this could potentially cost the end user or customer over $36,000 annually versus the monthly test that we do and the yearly test that we do. You're looking at a cost of about $34.50. I would say anytime that you're looking at a job where you have 100 or more fixtures that need to be used or batteries that need to be used, the inverter should come into play and should take that into serious consideration. How to apply an inverter? When you look at the total connected load, what I often recommend to our partners is if someone comes to you and they say they have 2,000 watts for their total load, just to be on the safe side, I always recommend adding 25 to 35% to that. And that's the best way to size a unit on the fly. And you can be pretty confident that you'll be okay with that. Voltage in and out, we need to know that, have to know that, because that determines a couple of things. It determines not only the size of the unit, will a transformer have to be used in the unit itself, and whether or not this is going to be a single phase unit or a 3-phase unit. what kind of loads are being connected, the devices. If you're not aware of this, with lighting inverters, you can also, especially on the LSN and our three-phase units, we can add small motors in conjunction with the lighting responsibilities for that inverter. We can do that. We just need to know who the manufacturer is of that motor and the size of the motor, and we can go from there. So this what comes up, just so everyone knows, most of you probably already do, what types of loads are controlled. We either have normally on or normally off. An example of normally on would be a luminaire or luminaires that we're using that are wired from the inverter to that specific luminaire. Normally off would be if we are wiring in, for example, an emergency lighting fixture. Bug eyes would be a good example of that. They are not normally on, they are normally off. So that's why they fall under that category. Where is the inverter going? Usually our inverters will be in the maintenance room. This is why sizing is so important, because as we all know, those maintenance rooms are getting smaller and smaller. So it's really important that we have the right size, because depending on the size of the unit, it will be accompanied by battery cabinets. So on the smaller side, you don't really have to worry about that so much. It's pretty basic. But when you get larger, like 12 and a half to 17 and a half, we're talking probably 2 up to 3 separate battery cabinets on our single phase units. So that has to be taken into consideration in design. The measurement data on our website, under our spec sheets, it will give you the exact dimensions, height, width, and depth of that unit, so you can plan for it as well. And we talked about the LSN. The LSN is our single phase unit, 1 to 17 and a half kVA. It's line interactive, which means that this unit is capable of running all different types of lighting fixtures and so forth. So we can cover that as well. Many different configurable options. Breaker slots in the LSN, we have up to 14 that can be used to monitor. We have an additional 6 that can be used on the unmonitored side. Usually we don't see that being maxed out, but we do have the room to support the customer's needs. 2 battery choices. We have our S-type and our G-type. Our S-type is our 10-year VRLA lead calcium battery. These are warranted. And then we also have the G-type, which is our gel cell, which is a 20-year VRLA lead calcium battery. Again, multiple output breakers. They can be ordered as normally on, normally off, monitored, or unmonitored. We do have a inverter sizing tool called Inverter Suite that not only our agency partners have access to, but we can also give access to your engineer customers, your contractors, and your electrical distribution customers. They can all have access to that tool. Very helpful, very self-explanatory. And if anybody ever needs any help with some training on that tool, I would be more than happy to help you with that. These are just some of the options. I felt it was important on our LSN that I'm not going to go through each and every one of these. We talked a little bit about our email device, a device that automatically notifies the user of system test results and alarm conditions. I also need to remind everybody, when we talk about lighting inverters, every lighting inverter, probably from about 750 VA all the way up to our max on our 3-phase, which is 125 kVA. Startup is needed. So this, after the contractor has installed the unit itself, they'll fill out a checklist. They'll send that checklist in, and we'll schedule a subsequent startup. This startup, the importance of this startup is when it happens and it's completed and everything's working properly, the customer will receive another year warranty on the electronics cabinet, which comes automatically with a year warranty. So you get a 2-year warranty on the electronics cabinet after startup, and then you have the 10-year warranty on the battery. In summary, We talk about load capacity and KVA, input output voltage, input output breakers, size and quantity. They do vary. I think they go anywhere from 10 up to, I believe we offer up to 100. Normally on, normally off loads, and any of the options that we discussed. Why do we want an inverter versus some of the other UL equipment that I've already mentioned? An inverter is a centralized system. It will cost the customer long-term less money to run and operate than some of those other systems. And they won't have to worry about necessarily failing an inspection because that information is recorded automatically in the lighting inverter itself. So with that, I'd like to thank you all for attending today. And if you have any questions, please feel free to ask those. Thank you.